We're going to take a look at a couple more examples from the probability sheet, mainly the ones that are verbal. Was working with some students and thought it'd be good just to take a look at a few things. So as we're looking at this question, it says, in a math class of 20 students, I'm going to highlight the stuff that I feel is important. Obviously, that one is. With 20 students, test was given the same day as an assignment was due. There were 11 students who passed the test, 15 students who completed the assignment, 9 students who passed the test and also completed the assignment. What is the probability that a student chosen at random from the class would have failed the test and did not complete the assignment? All right, so let's go ahead and set up a table first. So here we have a table, and we want to make sure that our table identifies what we have. So what we've got is a couple of things. We have the test and we have the assignment. So what I'm going to do is put our two categories. We've got our test on the top. We've got two options. We could have passed the test or we failed the test. Those are our only two options for the testing. The other thing we have is the assignment. It was a homework assignment, so it was homework completed or homework incomplete. So we're going to put our data, and what we also have, it says we have 20 students. That's going to be your number here to the edge. We've got a total of 20 students. So we're going to fill in our table with the appropriate information. It says right here there were 11 students who passed the test. Well, passed the test, 11 of them, that would be this entire column here, because we don't know if they did their homework or not, but we know that 11 passed the test. That's made up of this column that we see right here. So we put that as the total. Next thing it says there are 15 students who completed their homework assignment. And again, we don't know whether they passed their test or, what they did on the test. We just know that 15 students completed their homework. This is our completed the homework row. So we know that we are going to have a 15 here. And then the last thing it says, there are 9 students who passed the test and also completed the homework. Well, that's a combination of two categories here. Passed the test is this row right here. Completed their homework is this, I said row, I meant column, and then this row right here. So the intersection of those two parts is going to be 9. So now that we have this data, we have the totals, so we can identify what we have in each of these. We knew we had 11 total people that passed the test. 9 of those completed their homework assignment. Well, that means the remaining 2 did not. And that's a total of 12, just like you see in our column here. Next thing we can do any number of things, but I've got 2 out of 3 in my homework completed. So homework completed have 15 students, 9 of which passed the test. Well, that means 6 of those failed the test. All right, so as we move on, we know a couple of things, and these columns will sometimes check your work for you, because we had 15 that completed their homework. Well, that means that there were 5 that did not complete their homework, for a total of 20. For a total of 20. Well, if this is the case, we can do this numerous ways, because we have 5 total students that did not complete their homework. 2 of them still passed the test. That means the remaining 3 fail. So now this kind of double checks itself, because 6 plus 3 equals 9 and 11 plus 9 equals 20. These all should match up, just like you see them happening here. So we have a completed table. So now we need to take our data and go from there. It says, what is the probability that a student chosen at random from the class? Well, the class is a class of 20. So that's going to be our denominator. failed the test and did not complete their homework. Well, failed the test is made up of this column, and did not complete their homework is made up of this column. So the total number of students that failed a test at the same time they did not complete their homework would be 3 out of 20. Or if we change this to a decimal, this would be 0.15, about 15%. So hopefully this illustration here is showing you how we want to put these this data into a table and then create our proportion from there. We'll look at one more example. So as we look at this one, we see we have in a class of 25. Well, that's going to be our number down here as our subtotal because there's 25 students. 9 have cats. Let's highlight what we have. 9 have cats and 8 have dogs. There are 2 students which have both cats and dogs. What is the probability? Selecting the student. Let's go ahead and set up our table right off the bat here. What we obviously have is dogs. And if you don't have a dog, you fall into a no dog situation. Same thing on the other side. We have cats or cat and no cat. So we've got our table set up here. We know that this is a total of 25, so we want to see where the categories fit. So it says 25 students, 9 have cats. Remember, this is our have cats row right here. We don't know what they have on dogs. All we know is they have a total of 9 cats. So that's going to be our total amount on the row here. Next thing it says there are 8 people that have dogs. So that would go there. And you're more than welcome to fill these in. Well, if 8 have dogs, that means that 17 have no dogs. And over here, we could say if 9 have cats, that means 16 do not have cats. Because these have to add up to our ends here. So we can set it up this way. It really does not matter. It's completely up to you. So the last bit of information we have here are 2 students have cats and dogs. So that would be these 2 right there. That is the intersection of the 2 columns, the cat row and the dog column. So that's why we chose to put that there. Well, if of the 8 dog people, 2 of them have cats, that means 6 of them do not. Now, if 6 of the no cat people do have dogs, that means that 10 of those, or excuse me, have dogs, then 10 of those would not have dogs. So there's 10 people that have no dog or cat situation. And we added that up to equal 16, so that's how that works. And then how you look at this next one's completely up to you. It almost checks its work for you because 2 plus 7 equals 9 and 7 plus 10 equals 9. So we know that this last thing, cats with no dog, that would be 7 people. So we've got our table set up. Let's read our probability statement. It says, what is the probability that a student has a cat given that they do not have a dog? So if we are talking about this, we're only drawing from, because it says given that they do not have a dog. Well, what that means is we are only drawing from the people that do not have dogs. That would be this section right here. And the population of people that have no dogs is 17. So that would be our denominator. And it says, what is the probability that a student has a cat? So in our column, we're looking for the people that do have cats and the people that do have cats. Follow in this row, and that would be 7. So our probability statement is going to be 7 out of 17.